Our focus standard for today's lesson comes from Grade 7, Ratios and Proportional Relationships, Standard 3. Use proportional relationships to solve multi-step ratio and percent problems. Our topic comes from Proportional Relationships, Multi-Step Ratio Problems. Our essential question is, how can we use our knowledge of proportions to solve multi-step ratio stories? Please take a moment, pausing the video if you need to copy down the topic and essential question in your header, along with today's date, sub your question column in your note column, and resume the video when you're ready to begin. Multi-step ratio stories and proportion problems can take a lot of forms, but there's 3 basic tips that I would always suggest. First, write out a plan to solve. Write out the questions that you have and that you need to answer to be able to completely solve the problem. And then work just one step at a time. Don't get too overwhelmed by it. And pay very close attention to the units. Oftentimes in these types of problems, they like to give us measurements where maybe they give it in minute time and minutes in one part of the question, but then ask for an answer in hours. So they might change up the unit of measurement. With these 3 tips, let's go ahead and get started on our first problem. In this first problem, we read that Rebecca got 3 problems wrong for every 9 problems she got right on the math test. How many problems did Rebecca get wrong if there were 24 problems altogether on the test? So sometimes with these problems, we're tempted to jump right in and start calculating and multiplying and dividing things, but let's go back to that first tip. We want to write out a plan to solve. So the first thing I always like to figure out is what am I being asked specifically to answer, and to do so in a shorthand. Well, the question asks how many problems did Rebecca get wrong if there were 24 problems. So I like to write that just a little bit shorter. I leave a blank or maybe put a question mark or variable for how many wrong out of the 24 problems total. Okay? Well, what else do I know? I like to write that down too, so I know that she got 3 problems wrong for every 9 problems she got right. So I want to make note of that too. So that ratio from right here is that she got 3 wrong to 9 right, 3 to 9. But it leads me to ask another question. What is this total? If we know she got 3 wrong to 9 right, we should be able to just add them together to know how many total problems we're talking about in this ratio. That's right, we're talking about 12 problems. So now we know the ratio is that she got 3 wrong out of 12 questions. Now that we've kind of written out a plan of what kind of questions we need to solve, and actually we've started solving them, to set up a proportion that would help us answer our question about how many she got wrong out of the 24 total problem. So that ratio, using the information we know so far, or that proportion, might look something like this. We knew originally that she got 3 wrong to every 9 that she got right, and this was talking about a total of 12 problems. So since we want to make it match the ratio that we're being asked for, of how many she got wrong out of the 24 total problems, it would make sense to set up proportions where we're comparing how many she got wrong to the total amounts. So that first ratio, as you see here, is 3 to 12. 3 wrong out of a 12 total problems. So what can you do with this ratio and this proportion of equivalent ratios to solve the problem? Well, you probably saw that we could just multiply 12 by 2 to get 24. And since we're making them equivalent ratios in this proportion, we can just do the same thing in our numerator to figure out our answer. In working our way through this and solving our proportion, where we saw that we could just multiply this ratio by 2, we see that she got 6 wrong out of the 24 total. So now we just need to fill in our blank here. So there we go. We wrote out a plan and with questions and information that we knew, and then just worked our way backwards one step at a time until we could solve. Let's try another one. In our second problem, we're looking at a recipe for chocolate chip cookies that makes 5 dozen cookies. Each cookie is about 95 calories. Jay decides to use the recipe to make chocolate chip bars instead and yields 80 bars. Jay eats 3 of his chocolate chip bars. How many calories does he consume? So again, we're going to just take this and start by restating the question, kind of shorthand, what is the question asking us, and then see what other information and questions that leads us to until we have a full plan. Then we'll just work it one step at a time until we solve. Well, right here is our question. It says if he eats 3 of his chocolate chip bars, how many calories does he consume? So one way to note that would be leaving a blank or a variable for blank number of calories in 3 bars. That's what we're being asked to solve. So what other questions does that lead us? Well, it might be helpful to know this as a unit rate, to know how many calories are in 1 bar. And in order to figure out how many calories in 1 bar, we need to know how many calories are in all of them. He makes 80 bars, right? So in order to know we have to know how many calories are in 80 bars. So this is what Jay makes, but he's using this, right, as we work our way back through the problem, he's using this in a recipe that makes 5 dozen cookies, and each cookie is about 95 calories. Well, that's a rate that we probably need to note down. So using this information, we can ask ourselves things that we need to know, such as we knew the rate each cookie is 95 calories, but we're talking about a recipe that makes 5 dozen cookies. So we need to know how many calories to 5 dozen cookies, and we need to know how many cookies is 5 dozen, right? So we've worked our way through this problem and we've listed out the things we need to know to answer the question, how many calories in 3 bars? So we're ready to start working our way through it. Can you start using this information to figure out maybe how many cookies is 5 dozen and how we might set up a proportion using this information to start to answer this first blank? Go ahead and pause the video to think about it and check back when you're ready to compare. Using this unit rate right here, we can say we know that there's 95 calories per 1 cookie, and 5 dozen cookies, well, dozen is 12, so 5 times 12 is 60. So now we're just trying to figure out, using this rate and this ratio, how many calories in 60 cookies. Can you do some math to find that answer and help us fill in this first blank? Well, if you notice down here, to get from 1 cookie to 60, that we could just multiply by 60, I'd agree with you. And of course, to keep this equal, we'd have to do the same on the top. So let's do some calculations to finish this part. 95 times 60 gives us 5,700. So we filled in this blank right here. And so now we know that if there's 5,700 calories in the 5 dozen cookies, that's also how many calories there were in the 80 bars. So we can fill this in too. So by doing this work down here, we have a good key to getting closer to answering the question of how many calories he consumes in 3 bars. So using this, can you set up a ratio and a proportion where we can answer that if there's 5,700 calories to 80 bars, to figure out the unit rate for how many calories in 1 bar? Your proportion might look something like this. 5,700 calories to 80 bars is equal to some number of calories to 1 bar. What do we need to do to complete this proportion? That's right. We just have to divide by 80, because 80 divided by 80 will be 1, and we can take 5,000 700 calories, divide that by 80, and we'll have our answer for how many calories per bar. So 5,700 divided by 80 is 71 and 2500ths. So now that we know that there's 71 and 2500ths calories per bar, we just have to multiply that by 3 to get our final answer. Let's go ahead and calculate that out. So our final answer is that he would consume 213 and 7500ths calories in 3 bars. That's going to conclude our video today on solving multi-step ratio problems. I hope these tips were helpful, and I look forward to solving more problems like this with you in class.